All right, today we will start 6-2. We will spend one day today talking about multiplying radicals, and then tomorrow we will talk about dividing radicals. So it's the same section, but just kind of breaking it into 2 days. It's a lot of content, so it's nice to kind of split it up. Okay, so when we're simplifying, yesterday everything was perfect. They were perfect squares, perfect cubes, perfect fourths. Today, not everything will be perfect. So this first example, we're starting with a square root, so something that we should be familiar with in doing the square root of 4 times the square root of 5, because 4 is the largest perfect square that divides 20. I'm going to have the x squared in there as well, so you can separate it out if you want, if that's helpful. So when I take the square root of 4, I get 2. Remember, if you can take the square root, you will not have the radical there anymore. I can't take the square root of 5, because that will give me a messy decimal, so that I will leave. I can take the square root of x squared, that would just be x. Okay, now this direction does say assume all variables are positive. Yesterday I would have put absolute values around that x. Today I would not be, because it says assume that's a positive x, so then it wouldn't affect that. So 2 and x, remember everything's multiplying right here, so I just put the times to remind myself of that. Everything should come out to the front that came out of the radical, and then your radical will be less. So 2x square roots of 5. I believe all of your homework says assume all variables are positive. I think the problems just get more difficult, so then they don't want you to have to worry about the absolute values with that. Possibly, not sure why. Okay, for number 2, we're going to do another square root again. So you're looking for that largest perfect square that divides 98. Usually students have trouble with this one because it's 49 times 2 gives you 98. Okay, that 2 is still on the outside. The x is still inside. I'm going to take the square root of 49 and get 7. And now that 7 can multiply the 2, since they are both outside of the radical. I can't take the square root of 2. I can't take the square root of x because that's only to the first power. It'd have to be 2 or more. So that means 2 and x will stay in the radical. And then I'd have 14 square roots of 2x. Okay, now let's hop to if we have things like cube roots and fourth roots. Okay, ones that we're not as familiar with simplifying when they are not perfect. It's the same concept though. I'm looking for a perfect cube, then that divides 1,250. So let's remind ourselves of some perfect cubes. So anything to the third power is going to be a perfect cube. So maybe you're familiar with these from doing the problems from yesterday, maybe not yet. A lot of times I'll put, if I'm working on this on my paper, I'll put the first few perfect cubes on my paper. Okay, I can get these from my calculator, 2 to the third, 3 to the third. I don't necessarily have to memorize them, and I can just write these down. It's at the top of my paper, when I take my quiz or whatever. Okay. So from here then, when I look at this, 125 is my perfect cube that divides 1,250. It would go in 10 times. Okay, I'm going to get rid of this so I have more space. Okay, and then I have the cube root of x cubed. Okay, so the cube root of 125 is 5 because 5 to the third gives you 125. I cannot take the cube root of 10. Okay, the 8 would be the smallest perfect cube, and 8 doesn't divide 10, so that's going to stay in your radical. And then the cube root of x to the third would give me just x. Okay, so everything that is outside of a radical comes to the front, and then I will do the cube root of 10. Now be very careful. If all you do is just put in a square root, it's going to be marked wrong in Math Excel. You will need to change that index. Okay, so make sure you're paying attention to when you are typing that in. Okay, for number 4, now I'm looking at fourth roots. So I'm looking for, is 64 a perfect fourth? It's not. Let's write down some perfect fourths. So 2 to the 4th is 16. 3 to the 4th is 81. 4 to the 4th is 256. Okay, it already gets big really fast. So you can write a few of those down. You can write some perfect fifths down. That's my suggestion. And then you're only using those numbers. So I can only look at 81 is already too big. So then I'm going to 16. Does 16 divide 64? If it does, then we're going to simplify it. If it doesn't, then I'm leaving 64. Okay, so you shouldn't be, I'll see students do problems like this and they sit there and I'll divide it by 2, I'll divide it by 3, I'll divide it by 4. No, you're wasting your time. I am only going to divide it by perfect fourths if I have a fourth root. Okay, so this problem, there is only one option to try. So when I have students that tell me this is guessing and checking, not really, because you have to know what you need to divide it by. Okay, so then this would break into the fourth root of 16 times the fourth root of 4. And then I've got the fourth root of x to the 5th. The fourth root of 16, remember, is 2. Careful with that. I will have students that will put 4 because they took the square root of 16. Okay, that's what you're used to, is square roots. We got to retrain our brain here. And then the fourth root of 4, there's nothing to the 4th power that gives you 4. So that's going to stay. Now, there is something I can do with the fourth root of x to the 5th. Okay, if my exponent is smaller than my index, 5 is my exponent, 4 is my index. If that number is smaller, I can't do anything with it because you're looking for something to the 4th power that gives you that. Okay, if it's smaller, you can't have something to that power. Okay, so I can break up x to the 5th. What I hope my exponent would be a 4. Okay, if it's a 4, I can take the 4th root of x to the 4th. But I can't just turn 5 into 4. I need to turn, well, x to the 4th times x to the 1st gives me x to the 5th. So I'm breaking it into 2 radicals that would multiply to be the same thing. So I haven't changed the value. Just like I did with 16 times 4 to get 64, I'm writing x to the 4th times x to the 1st. Okay, so from here, I can take the 4th root of x to the 4th and get x. Remember, we said assume all variables are positive, so I won't need absolute values. I can't take the 4th root of x. So I've got the x and the 2 that will come out in front. Don't forget, you're going to need to put that index as a 4. And then I've got 4 and x. When you start writing this down on paper, you'll notice that it can be a little confusing when you look back at it. If I write 2x and a 4 and 4x. Now that 4 up there, you might not know, is that 4 supposed to be the exponent on the x, or is that supposed to be the index? So as you're writing these things down on paper, be careful in how you are writing it. So when you look back at it, or if you're writing this down on a test, it's not confusing for me or you. So sometimes I make this, I don't know if this part has a name, I make that extra long and then put the 4 there, or I've seen students do things like they add a little landing spot, I don't know what you want to call it, for that 4. Okay, whatever's going to work well for you, but just keep that in mind that can be confusing. Okay. All right, we got 2 more here. So for number 5, I'm doing a cube root again. So if it's helpful, look back at some of your perfect cubes. I'll just write them down again right here so they're in front of us, but you should see them on your paper. Okay. So start checking, do any of those divide 500? 8, 27, 64, 125. Okay? So 125 would divide 500 4 times. Okay, make sure you get in the habit of writing the little 3's next to those numbers. The 2 is still out here. Okay, because what I'll see students do when they just they're being lazy with it or they forget. So the cube root of 125 is 5. That's done. When they don't write the cube root of 4, then they start to take the square root of 4, which is 2. But I'm not taking the square root of 4. I'm taking the cube root of 4. So make sure it is important that you write that. If you forget to put it on Math Excel, it'll mark it wrong. If you forget to put that part down on a test, I will take points off, okay? Because it does mean something different. All right, so we'll come back up here. I haven't taken care of the cube root of x to the 5th or the cube root of y to the 12th. All right, so similar to what we did with a previous problem, I'm taking the cube root of x to the 5th. 5, that is a number that's larger than my index 3. So that means I can break this up into 2 radicals of x to the 3rd, and then what's remaining would be x to the 2nd. Okay, and then also I can take the cube root of y to the 12th. Remember we talked about, well, what to the 3rd power gives you y to the 12th? Well, y to the 4th, because 4 times 3 gives you 12, or 12 divided by 3 would give you 4, so y to the 4th would come out. Okay, so I'm going to put together 2 times 5 to get 10. I'm going to pull my y to the 4th out over here, and then I might just continue to write the rest of this. So the cube root of x to the 3rd is x. I cannot take the cube root of x to the 2nd. The exponent is 2. That is smaller than my index. I will not be able to do that. That's going to stay in my radical. I already pulled the y to the 4th over. So I just need to get this all organized into everything that's outside the radical goes to the left side on the front, and then everything inside the radical is under 1 cube root radical. Okay. It doesn't matter where my x goes. It can come after or before the y. Typically, in a math book, they put it in alphabetical order. It doesn't matter. I just put in alphabetical order out of habit. So then I've got the cube root then of 4 and x squared. Okay. With 6, I'm looking at a 5th root. So we haven't done a 5th root here. So 2 to the 5th is 32. 3 to the 5th is 243. And it's already really big. So I'm looking for, I can't do 243. Does 32 divide 48? No, it doesn't. So that means I can't simplify 48. So that's going to stay in there. Okay, so that stays. So that's going to be in my final answer. I'll put it below. Okay, next, x to the 4th. Well, I can't find something like what to the 5th power gives you x to the 4th because the 4th power is smaller than the 5th power. So that's also going to stay. So this problem isn't very difficult. Y to the 12th. Now I'll have to do something with y to the 12th because 12 is smaller, or sorry, 12 is larger than 5. So I can break that up. Now there's a couple different things you can do. If you think about the way we've been doing it, we hope that it would be y to the 5th, but then you're left with y to the 7th. Okay, and then y to the 7th can be broken down again. Y to the 7th would be broken down into y to the 5th and y to the 2nd. Okay, so I've got the 5th root of y to the 5th is y, and this 5th root of y to the 5th is y. So I'm taking y times y to get y squared. And then I'd be left with this y squared inside of my radical. Okay, so that would be my final answer. So you could, your y to the 12th could have been broken into y to the 5th times y to the 5th times y to the 2nd is what, I should put the radical, I ended up doing. Or if it's easier for you, instead of, if we get a really large number here, I have to write this out a bunch of times. So that can get annoying. So sometimes I'll tell students, well, remember you're kind of dividing that 5 into 12. Okay, so think about what is the largest number 5 could divide that would be smaller than 12. So that would be 10. So I could break it into y to the 10th, and then what's remaining is y squared. So the y squared is what stayed inside. The 5th root of y to the 10th is y squared, and that's what came to the outside. To me, that's quicker, but for some students, that's more difficult. So they just want to always go, well, I'm just going to use the exponent that is my index, and I'm just going to use that as many times as I need, and I can do that every single time no matter what. Up to you. Okay? All right, so that's the simplifying part. And then we'll look at a few multiplying problems. These aren't necessarily a lot more difficult. You're just going to multiply and then you're going to simplify. Okay? And once again, we're saying assume that they are all positive. And as long as you have, up here it's talking about as long as you have the same index, you can multiply them together. Okay, which we should hopefully understand that concept, because that's what we've been doing the whole time, is we've been taking something that's already in that form and changing it to a product of two radicals when we break it apart. Now we're putting it as one. Okay, so remember, anything that's on the outside of the radical can be multiplied together. Anything inside the radical can be multiplied together. Okay. And then from here, now I'm doing the same thing. I'm going back to perfect squares. So I'm looking for the largest perfect square that divides 180. And then you'll start to realize square roots are probably the most difficult, because you start to list out all your perfect squares. Right, and there's more and more, versus look at the perfect fifths I had to write out. I only had to look at one of them, and then it already got too big. Like, we've got to look at like 8 different perfect squares sometimes before we can find the right one. So perfect squares actually take longer, but you should be more familiar with them. Okay, you'll find that 4 does divide 180, but that's not going to be the largest. So the one you should be using is 36. So the square root of 36, and that goes in 5 times. So what is the square root of 36? That is 6. I'll leave the square root of 5. And then 14 times 6 would be 84 square roots of 5. Okay. All right, for number 8, we'll go ahead and multiply these things together. You can do some simplifying ahead of time. I usually discourage it. Like, I can simplify the cube root of 24 a little bit, but I'm going to simplify it, and then I'm going to multiply them together. And then sometimes you have to simplify it again afterwards. So I usually just multiply everything together, so I'm only simplifying it one time. That is my personal preference. So I'm going to take 2a times 4, since those are both outside of the radical. So that would be 8a. They are both a cube root, so I'm able to multiply negative 6 times 24. Gives me negative 144, and then it has an a squared. All right, so I'm looking for perfect cubes. So look back at your, that's a 3. Look back at some of your perfect cubes. I'll throw mine up here again. Oops, that's a 3. All right, So 8, 27, 64, 125 would be some options. So when you start doing this, you're going to find out 8 divides it 18 times. So I'm going to use 8 and 18. Now there is a negative, so you have to put a negative in one of these. Typically your negative is the one that comes out. So I'm going to put it with my perfect cube. When you look at answers in a math book, they always have the negative coming out. I'm not sure if Math Excel will mark it wrong if you leave the negative in. I could see it doing that, so I would say get in the habit of always pulling it out. Okay, so then, oh, and I'll have my a squared left in here. All right, I'll carry the 8a down so I don't forget it. So I can take the cube root of negative 8. That would give me a negative 2, which will multiply the 8a, since those are both outside the radical. Inside of my cube root, 18 will stay because 8 can't divide it as the smallest perfect cube I have left to try. A squared will also stay. That exponent is smaller than my root, or my index, I should say. So this would be negative 16a cube root of 18a squared. All right, that is our lesson. So tomorrow we're going to continue practicing with basically simplifying, but we're going to add in the dividing part. So it's not necessarily more difficult, but usually this just takes a lot of practice and getting used to. Please reach out with questions. Students usually struggle a little bit with these lessons when they're first learning them. All right, good luck.